Good morning and happy Easter to everyone. I hope everyone's having a fantastic day today. So this is our video going over the solutions from test 2. I just finished grading it and have returned them all with some comments. And then with a note at the bottom of each email, hey, take a look at the video. All right, so problem 1. Problem 1, we are asked to calculate the reactions at point E and point C. I have the free body diagram on the right-hand side. I know that the starting point for me is equilibrium equation. So I'm going to look at taking the equilibrium. That doesn't even look like equilibrium system symbol. Let me try that again. All right. Summation of the forces about the x direction, because I'm noticing there are just two of them. There's an external force of 10 kilonewtons at B, and there's Cx. So that's why I've chosen to start at that point. Equals 0. Therefore, Cx is equal to 10 kilonewtons. And has been our, or has been the way I've been doing the problems. I'll go over and fill that in my drawing. Oh, and that's one of the ones we needed, so I can build that into my scorecard also, or in my problem statement, I should say. All right. Well, so my next plan of attack is I need to find Cy and Ey. They are both, that's two unknowns though. So if I take the summation of forces in the y direction, I end up with two unknowns. So I'm going to start with taking a moment. So I'm going to take the summation of the moments about point E. All right, and I'm going to do a little bit different since they're all 10 kilonewtons except for the reaction. I'm going to start out with the very generic equation. All right, so it's the it's AY times some distance plus BX times some distance plus the external force 10 kilonewtons at point C. I'll just put a little C right here so we know that one, times some distance plus Cy times some distance is equal to 0. Okay. All right, so AY. So AY, we're going to have to go out and find the distance for AY. We're looking for the perpendicular distance between point A and point E, which is this one right here. Okay, so we're going to need that. Now this is an equilateral triangle. So equilateral triangles, if you drop a perpendicular like that, that splits this member into two, so that distance is 1.5 meters. I'm gonna write that in. Now, if you didn't know that, you could calculate that you could calculate this distance using trig. So we'll do that, then we'll erase it. So let's see. You guys deserve straight lines, so straight lines it will be. There's EA. All right, so this is EA. That's E and that's A. That's probably a better way of putting it. We know this distance is 3 meters. If this here is 60, if this angle is 60, that makes this angle 60. That makes this distance 3 times the cosine of 60, which better be 1.5. It was yesterday when I worked out there, a couple days ago when I did the quiz, 1.5 meters. Okay, so that's where the 1.5 meters comes from. I'm gonna erase that because I'm gonna. I think we're gonna need that space. And you can always go back, rewind the video a little bit, pause it so you can get that stuff down. All right, so distance between the B. All right, so now we're looking for, let me get another color for us. We'll use this blue. All right, so now I need the distance between this distance here. So between B and A. So I need this one right here. Need that distance right here. That's what's going to go right here. So this one's a little bit more involved. Not more, I mean, it's not difficult, it's just a little bit more involved. So I really need to drop a perpendicular from B down to DC, but I need a little bit more information. So let's kind of gather that. I think I need distance BD here. So let me draw what we've got going on here. Oops. There's that. All right, so this is B. That is not B. Everybody knows that. Everybody but me, right? Because they're watching the video and you're like, that's clearly not B. That he meant to say D. This is giving us 3 meters. We know this is 60 degrees. If that's true, then this is the length of DB is 3 times the cosine of 60, which would be 1.5 meters. If that's 1.5 meters, now we have, just bear with me for a second. So I'm dropping a perpendicular down from line B. That's the distance I need. We know BD. We just calculated that. So that's B, that's D, that's 1.5 meters. That's 60 degrees. If those two things are true, that means that this distance here is 1.5 times the sine of 60 degrees, which is equal to 1.299 meters. 1.299 meters. So that's this distance here. Okay. I'm going to erase that just to kind of clean up the board. Remember, you can pause. All right. I think that just really kind of leaves us a couple other pieces. So, and I think they're fairly easy to get. So the 10 kilonewtons at C, the perpendicular distance between that 10 kilonewtons and point E is the entire 6 meters. And then from CY to point E is also 6 meters. We'll go over and get our distances now. Oh, well, let me fill some of this in. So AY is 10 kilonewtons. Just filling it in now. BX is 10 kilonewtons. All right, now we're going to go get our distances or our rotations. All right, let's see. So if we're rotating about point E and we're pushing down at A, that's clockwise, so that's negative. At point B, that's going to cause counterclockwise, which is positive. At point C, clockwise, which is negative. And CY, counterclockwise, is positive. Kind of doing the arithmetic out, this would be negative 15 kilonewton meters plus 12.99 kilonewton meters minus 60 kilonewton meters plus CY times 6 meters is equal to 0. I think that comes out to be negative. That doesn't look right, does it? Negative 75. Yeah, it does. Negative, I was going to say it was wrong, but it's not. Negative 62 kilonewton meters plus CY times 6 meters equals 0, giving us Cy is equal to 10.335 kilonewtons. It is a positive number, which indicates that I have the direction correct. 335 kilonewtons. I'll go ahead and fill that in. And it means that we can finish this problem off using the summation of the forces in the y direction. So what have we got? We've got negative 10 kilonewtons plus negative 10 kilonewtons plus negative 10 kilonewtons plus 10.335 kilonewtons plus EY is equal to 0. And if you add all that together, add to both sides, we get the calculation that the reaction EY is equal to 19.665 kilonewtons. So as oddball as the shape is, because we had to find some distances, I'm noticing that we are able to get all 3 of the forces using the equilibrium equations. Hey, there were a couple folks, I just want to acknowledge this. So I've got the answer up here. There were a couple folks who, instead of taking the summation about point E, they took the summation of the moments about point C. And doing that, you would calculate, the calculation gives us EY first. So I'm gonna work that out real quick just so the folks can see it. Same numbers, I think. You still got 10 kilonewtons times 1.299 meters plus 10 kilonewtons times 4.5 meters. That 4.5 meters comes from point C, comes from the 3 plus 1.5. Plus 10 kilonewtons times 6 meters plus EY times 6 meters equal to 0. These first 3 are all positive. They cause counterclockwise rotations about point C. EY causes a clockwise, and you end up with the EY is equal to 19.665 kilonewtons. Then you would do the summation of the forces in the y direction to calculate force CY. But all right, let me pause real quick so I can erase and we can get ready for problem number 2. Be right back. Well, thank you for your patience. I've got the free body diagram up for our truss for problem 2. The problem statement is use the method of joints to determine the force in each member and determine whether it's in compression or tension. So we're looking for AB, AC, AD, DC, and BC. All right, the first thing I want to point out that there were 2 errors that were most common in this one, so I'm going to point one out right now. If you look at the drawing on the test or on the paper, point D is being supported by a roller. Taking a look at the table, and I think it's page 82, the reaction to a roller support is a force perpendicular to the plane that it's sitting on, or the surface it's sitting on. So this plane is a up and down, so the reaction would be horizontal. Okay, so that's why I have only a dx and no dy. And so we'll start with that. There's my problem statement. All right. Looking at the picture, I'm going to start with the summation of forces in the y direction. The reason I'm choosing that is because there are only 2 of them. There's AY minus the 5 kilonewton external force being applied at point B. So AY is equal to, ta-da, 5 kilonewtons. I'm gonna fill that in. 5 kilonewtons. All right, that was fun. We need to get dx and ax if we can. What if I take the summation of the moment about point A? That leaves us only with two forces that cause rotation. Let's see, so let me erase that. Let's see what we have. So we have dx times the distance. So the perpendicular distance between D and point A is 1 meter. That worked out pretty nice. And there's also the 5 kilonewton force over at B. It has a perpendicular distance of 3 meters. Picking up direction, if I'm rotating about A, the force dx causes a clockwise, which is negative, and the downward force at B also causes clockwise, which is negative. You guys can probably figure out from here what's about to happen. It would appear that I have chosen the wrong direction for dx. Solving for dx, in fact, we get the dx is equal to negative 15 kilonewtons. The negative 15 doesn't mean the force is negative, it just means I've chosen the wrong direction. Go up here and correct that. So it should be that. 15 kilonewtons. And summation of force, well, so there's only two forces in the x direction. I had dx, the correct direction for dx is going left to right, which means the correct direction for ax is right to left. I'll go ahead and correct that now. And it's also 15 kilonewtons. You can do the summation of forces in the x direction, and it'll come out to be 15 kilonewtons, I promise. All right, now, so there were two places. You remember that in the method of joints, we have to pick a joints where there are only two unknowns. So you could have either started at point D or point B. I'm gonna start. The most popular starting point was at point B, so that's where I'm going to start also. Before I do that, I'm going to erase our purple stuff, our equilibrium equation, so we have a little bit more room. So we're going to start at point B. So when we do this, get us a good color. It will not be that purple fuchsia thing. Maybe we use green. Point B. All right, so we want to do a free body diagram of pin B. We've got couple things going on. We've got that external 5 kilonewton force, so let's put that in. There's member AB. I'll put that one in. Now this is a down. The 5 kilonewton external force is down. That means CB has to have a Y force in the that goes up to, since it's the only other Y. So that's why I've chosen that orientation. 5 kilonewtons. This is BC or CB. This is AB. What do we got going on here? So we need this. I need the X and Y component for CB. Let's look real quick over here at the picture and see what we have. Oh, we know it's 1 meter tall. From here to here is 1 meter. 3 minus 2 is how I got that. That means this is a 45-degree angle, as is this one. Okay. All right, so that's important to me in this way. Quickly. Well, not very quickly. We got plenty of time. Okay. CB, this is 45 degrees. That means this is CB cosine 45. And the y component is CB sine 45. Okay. All right. We are set to go. Well, summation of force in the y direction, I'm going to start with that. -5 kilonewtons plus CB sine 45 equals 0. CB is equal to 5 divided by sine 45, which is, I think it's 7.07 kilonewtons. I came out with the positive number, which would indicate that I have guessed the correct direction of CB. CB is being direct. The reaction of member CB is going into the point, which would be a reaction to CB being in compression. So 7.07 kilonewtons in compression. All right, so far so good. Knowing that, what else do we have? We have summation of forces in the x direction, -AB plus CB cosine 45 is equal to 45, or I'm sorry, is equal to 0, which is, we know CB now, 7.07 kilonewtons, cosine 45 is equal to 0. That gives us, if you solve for AB, 5 kilonewtons. I have 5, that came out positive, which means I have the correct guess. So the reaction to member AB is pulling away from the point would be a reaction of AB being in tension. 5 kilonewtons in tension. Okay, now I'm going to erase that. And then I want to talk a little bit. I'm going to go to point A next. So maybe we'll draw the free body diagram for point A, then we'll talk. Let's do that. Let me draw that. I'll be right back. All right, thank you for your patience. I've got the free body diagram for point A. I want to talk about it for a couple of minutes. So point A, of course, you know, we have the two reactions, 15 kilonewtons and 5 kilonewtons. We just calculated the reaction to the 5 kilonewton force internal to AB being in tension. So I've drawn an intention here, which leaves us our two unknowns, AD and AC. Okay, so so one would assume, looking at this free body diagram, that we would calculate a value for AC and calculate for a value for AD, and then from here, whatever value we got, we would go down. We would have everything we needed except for the member in DC. So I want to just briefly talk about that, and then we're going to go back up and look at point A. So this is the free body diagram for point D. Okay. Oops. There we go. Just kind of stick with me. I know it's a little bit out of order, and I have a error there, which means I have error there too. We know that this goes this way, which means this has to go this way because there's only one other one in the x direction. So if we do A, which we're about to do, we would calculate AC very easily, because we could just take you know, -15 plus 5 kilonewtons plus AC cosine 26.57 and get a value for AC. And then we would have, by the arithmetic, We would then calculate forces in the y direction, so negative AD, negative whatever the y piece of AC is, and then a positive 5, and you would get some value for AD. It would work, right? Then you'd get done. You'd write that over here on your scorecard. You'd be very happy because you'd be one member away. You'd come over here and you'd write some value in for AD. The problem is when you're at point D, notice that there's only one force in the y direction. There's only one force in the y direction. That means AD is a zero force member. So even if you came and you started out with point A and did the calculation, when you drop down to point D to calculate for CD, you should notice that there's only one force in the y direction. And because of that, that force has to be equal to 0, which means after you calculated CD, you'd have to go back up here and recalculate AD, because AD is 0, not some numerical value, okay? So knowing that, I'm going to write up here so I don't have to come back and redo it. AD is equal to 0. It is a zero force member. And again, you say, well, you know, Rick, you just know that because you're the teacher and you've done the problem before. Well, I know it because I started out at D and saw the AD. You know, my first joint was at joint D, and saw the AD was equal to 0. The second reason I know it, though, is as I worked through, you know, as I was checking some work today. So if you're getting a value for AD at pin A, and then you draw the free body diagram for pin D, and you put a value at AD, you better be looking at the entire free body diagram. And if you only have one force in the y direction, and you have a numerical value for that force, that should be a red flag, which would have forced you to reevaluate AD after you finished out point D. Okay, so that's kind of like my soapbox thing about that. All right, let's get our calculations here. So so I'm at point A now. Point A. Point A. So I'm gonna look at summations of forces in the y direction, because there are only two. It's the 5 kilonewton force minus the y component of AC, which is AC sine 26.57 kilonewtons equal to 0. Solving for AC, it's 5 kilonewtons divided by 26.57. The sine of 26.57, thank you, which is equal to 11.18 kilonewtons. Positive number indicates that I have AC drawn in the correct direction. That's in tension. In tension. Okay. I think we have enough room to do D, so I'm not going to pause. I will get a different color for us, though. It's always popular dark green. Point D. AC, which we've already discussed, is a zero force member. And we have 15 kilonewtons going there. This is a pretty quick one. I do like the fast ones. I notice you guys do too. So this was AD equals 0. This was DX, 15 kilonewtons. This is DC or CD, depending on how you wrote it down. Summation of forces in the x direction equals 15 kilonewtons minus DC is equal to 0. Therefore, DC is equal to 15 kilonewtons, positive number indicating I have the force drawn in the correct direction. Going into the pin, which would be a reaction to the member being in compression. 15 kilonewtons compression. All right, Let me pause, erase the board, and get number 3 up. Be right back. Welcome back, and thank you for your patience as I got the board ready with problem number 3. This one was problem number 3. Use the method of your choice to determine the force in member GH. All members are the same length, 2 feet, and indicate whether GH is in tension or compression. So by far the most popular method was the method of sections. There was one person who did it by the method of joints. A little bit more work, but I'm pretty sure that but it works out if you do it like that. It's a little bit more difficult because if if you're looking at this one, it was probably kind of hard to get the reactions at D, E, and F. By hard, very hard. So anyway, so I'm using the method of sections. I'm going to use the top section. The cut I'm going to make is going to use the top section. In other words, to get rid of the reactions at D, E, and F. There were 2 choices here. I'm going to be working off the right-hand picture, but I did want to acknowledge, I think it was Daniel, I think, used the left-hand picture. Now he made a cut cutting through 3 members. One of the members has to be the one that we're looking for. So he and someone else, I can't remember the other person, used the left-hand picture. So when he made his cut so that there were 2 sections, he cut through 3 members. One of the members has to be GH. I made the also the method of sections. I cut through members BC, BG, and GH. However, also 3 members, also cutting through GH, which is the one that we care about. I worked it out both ways. You get the same answer. I'm going to be demonstrating the right-hand side. Let me get rid of this so we have some room. All right. All right, let's see here. So let's kind of talk about what we have going on here. If all of the members are the same length, in other words, they're all 2 feet, then all the angles are 60 degrees. 60, 60, 60. So Joshua, if you're watching, I know they don't look like they're all 60, but they are, because they're equilateral triangles. And this one's a 30. Right? We're told this is a right angle. 90 plus 60 is 150. 180 minus 150 gives us 30, in case we need that. Let's see what we've got going on. So we've got all kinds of forces that are diagonal. So let me kind of think about this for a minute, how I want to go about it. We've got the 250 force is diagonal. So let's see. Yeah, we do it in black. So there's the 250 kip force. Oops. There's the Y component or the X component. Sometimes I get them so confused. Not really in my head, but I say I'm wrong. There's the Y component. So this is 250 kips. That's a 30-degree angle right here. Oops. Oh, what the heck? Poltergeist or something. All right, that's 30 degrees. We talked about that in the intro. That makes this 250 times the cosine of 30, which is equal to 216.51 kips. And this one is 250 times the sine of 30 degrees, which is equal, it's 125, yep, 125 kips. I've worked this one out a couple times today. All right. Uh, if you would indulge me, I want to go ahead and get, well, let's see what happens. We'll see what happens. All right. Whoa. So lots of X's and lots of Y's, right? So there's potentially a BCX, BCS, BCX, and a BCY. There's potentially a BGX and a BGY. And then there's potentially a GHY and a GHX. What if we take let's take the moment about point B. And by doing that, we eliminate the need to worry about BCXs, BGXs, BCYs, BGYs. We'll just be focused on the one thing. Okay. All right. So let me kind of move this backwards to unclutter everything. All right. So we're going to take our moment about point B. All right. So we're going to take our moment about point B. Okay. So far, so good. All right, so that means we are going to have to do a little bit of work with GH, but I'd rather just do one than like all of those. Okay, this is GH. This is 60-degree angle. So this is GH times the cosine of 60, and GH times the sine of 60. Okay, I think that's going to be, I think we have everything else, right? We'll see. All right, moment about point B. So GX is not a player. GY is a player though. So GH sine 60 times 2 feet. All right, perpendicular distance between point B and point H is 2 feet. We were told that member is 2 foot long. We've got the distance between, oh yeah, there's that, right? We need the distance between point, we need this distance here. We sure do. And we're gonna need this distance here. So let's see. We're looking at, we'll start with this one. What's the distance between this 125 kip force right here? The distance between that and point B. So this is a equilateral triangle. Remember, I think it was in the second problem, equilateral triangles have the property that we proved, you know, like the great geometrist. But we proved that if you have equilateral triangle and you drop a perpendicular from the top, that it bisects this, like right here. So if this is 2 foot, this is 2 foot, and we know that these are all 60. Each one of these is 1 foot. So that makes the distance, if from I to A is 2 feet, then this additional piece right here is 1 foot. Okay. Let me get out of pink, back into what I was in. So plus 125 kips times 3 feet. And then we have plus 216.51 kips. And now we're looking for another distance, right? So we're looking at this distance here. So essentially this altitude. Well, I mean, there are a couple ways to go about it. Probably the easiest way is using trig. Could use the Pythagorean theorem, but I don't feel like it. So that's 60. That's 2. I think that means that this length here is 2 times the sine of 60, which is 1.7321 feet. So this distance here. I'm gonna make a big star. And then this is a big star down here, just as a reminder. 17321. 1.7321 feet. All right, let's pull directions now. So if we're taking a point about B, B. The y value for GH is going to cause a clockwise, which is negative. 125 causes a clockwise, which is negative. 216.51 causes clockwise, which is negative. This would be. And we get that GH is equal to 750.017 divided, what would be a negative, divided by 2 sine 60, which is negative 433.02 kips. Negative being an indication that I've, of course, once again, shown the force in the wrong direction. So the correct orientation is the reaction is pointing into the pin, which would be a reaction to the member being in compression. So another problem similar to number 2, where there's a couple measurements missing. Luckily, the problem writer gave us everything that we needed in order to solve that. I'm gonna pause right here so I can get the board ready for the last of the problems. Be right back. All right, well, welcome back for the 4th of our problems from test 2. Problem statement. Calculate the reaction at point C. Use a free body diagram of BD or of AC to help you. I started with the full body diagram of the equation. I'm going to solve for the reactions. As I change the pen color, I want to talk about it for a minute. When I'm looking for the reactions to the supports at A and B, I at no time have we worried about like a reaction at what's going on at point C to find the support or reactions to the support at A and B. So there were a couple of folks who started their problem out by saying, well, I've got to include CX and CY in my equilibrium equations for the entire structure, and that's just not true. We've not done that. We didn't do that with any, like for example, the trusses that we worked on. We never did that. So I'm not entirely sure where that came from, but that's not the approach that we want to take. Okay, so let me erase that. And so that was the most common error for this one. All right, we've got 2 unknowns in the x direction, 2 unknowns in the y direction. That's an indication that we're probably going to need to start out with taking the summation of moments. So I'm going to take mine about point B. By taking about point B, that makes BX a non-player, BY a non-player, and AX a non-player. We've got 400 newtons. The perpendicular distance between D and B is 0.2 plus 0.4, which is 0.6 meters. And we have AY. Perpendicular distance between point A and point B is given as 0.3 meters. Grabbing our directions, if I'm rotating about point B and I'm pulling at point D, that's clockwise, which is negative. AY is also negative. Big surprise, I guess wrong again. Solving for AY. you get 400 newtons times 0.6 meters divided by negative 0.3 meters. AY comes out to be negative 800 newtons. Oh, I wrote in red. That's right. So we'll correct it in green. How about that? So AY should be 800 newtons going up. That means that BY is also wrong. BY needs to be down in order to counteract that. And by inspection or by the equilibrium equations, BY is also at 800 newtons going down. We cannot solve for AX or BX. So hopefully we won't need that. So let me erase my left-hand stuff over here. So the hint was either use the free body diagram of, let me read the exact words. Where did I put it? BD or AC. I initially worked mine using AC, so that's kind of what I'm going to do for this one. So there's AC. And then I'll work it the other way also. All right. So AX, which we have yet been able to figure out. We've got an 800 kilonewton at AY. And so this is going to be CY, and this is CX. Well, we could tell that CY is equal to 800, right? I mean, there are only two in the Y direction. One of them is 800 up, so that means the other one has to be 800 down. So I'll fill that in. Okay. Well, I'm gonna have to take a moment, right? So I either take the moment about point C or the moment about point A. I did my calculation around point C, so that'll be the one that I demonstrate. It takes out CX, leaving this only with 800 kilonewtons times some distance plus AX times some distance. With 800 kilonewtons, the perpendicular distance between point A and point C is 0.3 meters. And the perpendicular distance between AX and point C is given as 0.4 meters, so it wasn't too difficult at all. Equals 0. If we're rotating about point C, 800 is going to move it clockwise, or I'm sorry, counterclockwise, which is positive. AX is going to move it clockwise, which is negative. So AX is equal to negative 800. I'm subtracting 800 times 0.3 from both sides. Hopefully that's newtons. Divided by negative 0.4 meters. And I get that AX is equal to 600 newtons. Positive number. Correct direction. Oh, that's all I needed, right? I'm sorry, AX was 600 because 6 is the only other one in the Y direct or X direction, then it also equals 600 newtons. And if you use the Pythagorean theorem, what do you get? I didn't really work this part out, but we could do it quickly. There were a couple of folks who solved specifically for C at the end. So let's see, 600 square. 600 square is 360,000 plus 800 square is probably 640,000. That gives us total million. Square root of that is 1,000. These were the two answers that I were looking for. If you did this, I accepted that as well. Okay. All right, so I'm gonna pause real quick. I'm gonna erase the left-hand side because I do want to show it the other way that I saw worked it. I'll be right back. All right, this time, so again, the problem writer says, hey, you could have also done a free body diagram of member BD. So that's what I've written on the left-hand side. And we could have solved the problem that way. Let's see if we get the same answer. I sure hope so. So I'm gonna start with the equilibrium equation in the y direction. We've got the negative 800 kilonewton, which was the reaction of By plus Cy is equal to 0. Solving for Cy, 800 newtons, which is the same, yay for us. Go ahead and see, I'm looking for if I take a moment about B, that will give me Cx, I think. So let's see if that's true. A moment about B. Cx is a player. We know that the distance is 0.4 meters. 400 newtons is a player. We know the distance is 0.6 meters. Directions, if I'm about point B, Cx is going in a counterclockwise, which is positive. 400 newtons causes a clockwise, which is negative. So Cx is equal to 400 newtons times 0.6 meters divided by 0.4 meters. Also gives us, let's see, 312, 600. Also gives us 600 newtons, which is also correct. So either way would have worked, which is refreshing, right? We say that's supposed to happen. We say that in class all the time. It doesn't matter where you start from, as long as your choices, you perform each step of your choice correctly, we should come up with the same answer. And it proved that it did. All right, so that's the solution. I'll post it on our YouTube channel. Probably, I don't know if I'm going to do a lesson tonight or tomorrow, but certainly there'll be one up either today or tomorrow. Hey, have a great day. Enjoy your weekend. I'll talk to you tomorrow.